Welcome. I am Michael and I will be talking to you today how I use political science concepts to understand my job better. I will talk briefly about what political science is, and then I will deep dive into two topics: team building and system design. Why am I talking about political science? My university education is in political science after a brief stint at computer sciences. I spent a few years learning about concepts like Arrow's paradox or perpetual peace. No joke, the latter is a interesting short text by Kant. On a more serious note, I focused on European politics. I am not expecting that you share my passion, although I'm hoping, and I also do not expect any prior knowledge on political science. Thankfully, nowadays I rarely get asked what I'm going to do with my studies when I grow up. People half-jokingly suggested head of government, but that is a political office and there is a huge difference between political science and politics. Political science, like any other science, is about understanding, explaining, modeling and predicting what is happening in politics. Politics, that is roughly speaking the interactions, debates and struggles about how we are sharing common goods or how we live together as a community. If you are, like me, not a native speaker, there are three closely related terms that might cause confusion: politics, policy, and polity. Their common origin is the Greek polis, city. Politics refers to the interactions in the city or community. Policies are rules, some of them created by politics, some of them regulating politics. Polity is a group of people sharing a set of policies. Because of the predominance of the nation state in the late 19th and the 20th century, the most commonly analyzed polity in political science is the state. I will start from there after clarifying how political science relates to other sciences. Political science is part of social science. But what is the distinction to sociology proper? Sociology is researching human, as in social beings, interactions. Is political science then researching social interactions in the state? More broadly speaking, in a polity. That would give us a somewhat fuzzy line of separation between the two domains, just determined by the character of the community we research on. It gets more clear if we pick the analysis of power in social interactions, or the analysis of social interactions that are characterized by the presence of power. By the way, we could spend days arguing about the definition of politics, or political science for that matter, and about methods to use in political science. For this talk, you have to bear with me on the choices I have made for you. I should not be too far from a common ground or mainstream political science. Discussions about politics have probably been happening since humans started to communicate with each other. Philosophers described how to lead a good life and how to interact with other people. Their focus was on the how, though, and if you want to read up on this, search for political philosophy. You can discover authors like Plato, Machiavelli, Locke, Kant, Rawls and Foucault, and it is fascinating how that thinking evolved. However, political science is a fairly new domain. It basically starts after World War II in an attempt to understand how to avoid wars, or at least large-scale international conflicts, and to understand why societies selected fascist leaders. That is very similar to what historians have been doing and are still doing. Political science distinguishes itself by a clear impetus to discover the generic mechanisms to develop models looking forward. But yes, that is another fuzzy line. Focusing on the analysis of power as a criteria for differentiating helps only partially. However, that is also not what I want to talk about today. I mentioned the historic origins of the domain because this gives us a starting point for the talk. Some of the first political science work was research in international relations, avoiding future wars. I will start with a short history of international relations theory and generalize this with some game theory. I will then bring back politics with power, and I will close the first part by talking about social change. For the second part of the talk, I will take a specific theory, Luhmann's social systems theory, and use a few of his ideas to talk about system design and debugging. Luhmann identifies complexity as a problem, and I believe it is interesting to look how he tries to solve it. A note on sources. You find some key references in the supporting material, and I am mentioning direct sources, obviously. I am happy to provide more pointers if you might have specific questions. Before I start with the first part, the method I apply today is the same in both parts. I am picking a subset of political science research and applying it to everyday challenges I am facing as a site reliability engineer. There is an abundance of literature about team building. I have been exposed to a few of them, and I guess it has been similar for you. Sometimes, as I found a concept not particularly convincing, I noticed that I was using political science concepts to rationalize and explain why not. Most of the methods did not provide an explanation why I should be doing in that specific way. And that obviously piqued my interest as a political scientist. Because team building is social change applied. You change the rules of how a group of people is working together, and you make those people follow the rules. A high-performing team has an efficient set of rules internalized. I will endeavor to explain in the next 10 minutes why I think that there is exactly one way of doing that in a knowledge-based industry. For that, we need to understand concepts of power and how we can model social interactions. We then look at how change is happening in social interactions, and that under specific power conditions there is only one effective way of change. International relation theories provide a tangible approach to modeling power and social interactions. There are three key concepts or theories which I am going to label realism, liberalism, and constructivism. Constructivism is a fairly new approach, gaining popularity only in the 1990s, so we get back to it later. Realism and liberalism, in various variants like neoliberalism, are popular schools of thought after World War II. Realism postulates that the states are the key or only actors in international relations. As rational actors, they follow their own self-interest, starting with self-preservation. There is no intrinsic incentive for international cooperation and no superior power or rules that govern the relationship between states. To ensure their own survival, states must be more powerful than other states, or at least have enough deterrence to make an attack by another state unrealistic. Sounds familiar? But the arms race ended, or at least slowed down considerably with some international agreements, not possible in pure realistic thinking. Cue liberalism, which breaks up the state as a unitary actor and assumes that there are multiple interests states represent. Starting with economic interests, proponents of liberal ideas argue that states can enter cooperation agreements to foster their common interests. On a more formal level, proponents of both theories later use game theory to explain or model. You might be familiar with game theories or rational choice from recent economic research, but it is fundamental for our modeling of social change. In that theory, a game is an artificial situation in which players act rationally but are bound by certain rules. And the idea is that if those rules and conditions are similar to reality, you can predict player or actor behavior in real life. You can argue about the assumption that players act rationally, but that is a different debate. They also assume that the basic entities and rules do not change. The most famous game is the prisoner dilemma, where two players are arrested, and if one of them cooperates with the police, the one that cooperates walks while the other goes to jail for a long time. If both are cooperating, they both receive a considerably shorter amount of prison time. If neither talks, they both walk as the police have no evidence. If there is no cooperation, coordination or communication allowed between the two participants of our little game, what is the most rational choice for each player? Because they can theorize about the rational choices for the other player, the common assumption is that they will confess. It is reducing their risk. However, if they could trust each other, it would be irrational to stay silent. They would walk free. In the case of the prisoner dilemma, trust needs to exist outside of the game. There have been attempts to show that if you allow cooperation between the actors, we are talking different game, different rules, it is possible to show trust. However, in any case, cooperation allows the actors to get into win-win situations. In international relations, the prisoner dilemma most closely matches realism. while liberalism allows states to cooperate. Another great example of how to build that trust is agreeing on certain values, respecting each other, for example, and with that, also assuming good intentions. If the other person is also respecting you, they probably did not want to send you to prison for a long time. At first look, realism has a more clear relationship with power, while liberalism is more about economic interests. But if we look closer, there are different forms of power, and that is what I will talk about next. In international relations or international law, the state is often defined as the only authorized source of violence towards other states by armed forces and towards its inhabitants by police forces. It is important to notice that this is not the daily exercise of physical force, but the constant threat of it. Weber, a famous sociologist, wrote, "Power can be defined as every chance within a social relationship of enforcing one's own will, even against resistance, whatever the basis for this chance might be." A state with a complex organization of police, courts and prisons ensures that a set of agreed rules is followed by its citizens, similar to our earlier game. However, it would be quite inefficient to enforce every single rule by violence or by its threat. A government has lost its legitimacy if it needs to apply large-scale violence, and this is not sustainable. Hence, most rules should be seen as somewhat legitimate to avoid high costs. Democracy, that is electing the people that vote about the rules that apply for all, is a common way of producing legitimacy. Note also that this model assumes a somewhat hierarchical delegation of power. Why is this important for team building? Classical management theories, some say, are from 19th century railroad construction work. The person most qualified to do the job is training others, and they move into management because they are able to plan and tell others what to do and when to do it. The premise of this model is that the manager knows exactly how to do the job. In a knowledge-based work environment, this premise does not hold. My reports possess specialist knowledge that I do not have, and I might have neither time nor skills to acquire it. I need to trust them. Also, that means if I try to tell them exactly how to do their job, I would be micromanaging, and you might expect that this would not end well. Hierarchical exercise of authority, or our first definition of power, will not be working in this world. There is an interesting exception in incident management, where teams switch to a comment-based structure. Most modern software development companies are knowledge-based environments, and they need a different form of power. I believe that network is a better match. You might think that this is funny or simplistic, analyzing a company that is an advocate of the free and open internet as a network organization, but there is a lot more to it than superfluous coincidence. Let's have a quick look at the key differences between hierarchical and network organizations. I mentioned the different distribution of knowledge and that this requires a different role of leader. I am using the term behind the scenes, describing someone who unblocks, enables. Individuals in a network organization need to maintain meaningful contacts for their daily work with a considerably higher number of other employees compared to hierarchical organizations. Which brings me back to Weber's definition of power. In a network organization, it is expensive to use power to force someone to do something. Changing processes or applying new rules by forcing employees to act differently is expensive. Is there a cheaper way to trigger change? Yes, let me explain. I briefly mentioned constructivism as the third important theory in international relations. It differs from the two previous ones in how it describes reality. It is ontologically different. Both realism and liberalism assumes that states or the actors are real, that they are not changing and that the rules they follow are given, although especially the rules are quite different. Constructivism states that this reality is a social construct, hence the name, and that actors are creating it with their actions. As an example, the nation state is a construct of the 19th century, and this construct is waging war against other nation states in the 20th century. Social constructs do matter. Now, this might sound like a very theoretical distinction, but it has practical consequences for team building because this actually allows me to explain how social change works. I mentioned rational choice or game theory earlier and identified two key components for analyzing social interactions, actors and rules. There was no possibility for the actors to change the rule inside their game. Obviously, we can assume an external actor that can set new rules, But then we need to explain this new actor's motivation. But if the rules are a social construct and are constructed by the actors, change is possible. In that view, actors do, by default, reproduce the rules by performing actions that are aligned with how they perceive the rules. But it is possible for them to act differently. And if that change is picked up by other actors, the rules have changed. Social change happened. This sounds easy or simple, but it is not how we normally look at reality. Remember, for this analysis to work in international relations, you need to look at a nation state with its military as a set of social constructs. Before we look at recipes for successful social change, there is an anti-pattern that I am borrowing from the French philosopher Pierre Bourdieu. He did not see it as an anti-pattern, for he saw it as perfection, excellence. If an actor takes part in the game by bending the rules without breaking them, they can use the game for maximizing their individual advantage without driving change. Do not get me wrong, this can also be a starting point for actually pushing for social change. However, it shows why values are so important for a company. If you have a bad actor that is only maximizing their own profit and not trying to do what is also good for the team and the company, it will decrease legitimacy of the existing rules because the others will realize that those rules are bad. I leave the rest to your imagination. But enough theory. How does this apply in real life? Let us assume that there is an existing team with a typical mix of tenure. They have a set of rules on how to deal with interrupts, that is, requests that interrupt them in their project work. Those rules are partially documented, but not everyone shares the same interpretation. They are a social construct. Over time, this diverges and increases load unevenly. Some team members work hard to close tickets, others understand the rules in a way that allows them to do some project work. A first attempt to fix this might be to rewrite or update the rules. Knowing all that I just told you, is this a good strategy? If you can apply direct power to change behavior, yes, but that is expensive. It will probably increase frustration. You could get everyone into a room to form a parliament and decide together on the rules. Something that might sound familiar to you if you have been working in Scrum or related agile approaches. If we apply our new theoretical background to this, it is probably an effective way to change the rules, but it is also quite expensive. Expensive this time because it requires all team members to spend time in the parliament, discuss and agree, we need legitimacy, and will lead to the famous complaint, too many meetings. If we try to apply what we just learned about driving social change, what would we be doing? Probably get together with a few motivated team members that want to change the process and start interpreting the rules differently. We could also ask for an experiment, saying we would want to do this differently for a certain amount of time and then evaluate, learn from it. You might have an idea on how the new rules should be, but you might not push for those changes, rather try something small and easy first that everyone can apply. Will that work? There are no guarantees. However, it is less expensive, requiring less time investment, causing less frustration. It will not be received as from above. On the contrary, it encourages a growth mindset and gives team members that are not entitled, that do not have formal authority, a chance to show that they can change how their team interacts. I would go one step further on a theoretical level in a society or company where the exertion of direct power is very expensive, what we called a network society earlier. This is the only reasonable way to drive change, to build and develop teams. My argument is based on the analysis of power in social interactions, the power to drive change, which is the framework specific to political science. This was the more practical part of the talk. Now let's get into some serious system theory and how this can help you with designing and debugging. So far, my key focus was team building with the understanding that political science provides about social interactions. System theory is a somewhat specific and abstract approach to analyze systems, political communities, or a production environment. I will explain in a moment. I just described the constructivist turn as an understanding that actions do matter because they create structures. They reproduce institutions or systems. This is very similar to the concept of autopoiesis. That is a modern combination of two Greek words, literally self-making. It is used to describe a system that can reproduce itself by creating elements needed for its survival. This has a few interesting implications if applied to social science. Luhmann did this, claimed a change of paradigm, and developed a theory of self-referring systems. His general theory is a 660 pages book. Today, I can only scratch the surface of it. However, Luhmann actually suggests that it is possible to start from any part. Let me then start with a quote from Luhmann that I roughly translated. Accordingly, complexity means necessity of selection, which means contingency, which means risk. Keep in mind that contingency in German is a highly scientific term. I do care about reliability, and any risk reduces reliability. What does Luhmann suggest to reduce risks? I will get back to this. However, the answer might be disappointing. To understand better if Luhmann's connection between risk and complexity applies to site reliability engineering, we need to look deeper into his approach on system theory. System theories in social science received a lot of attention in the second half of the 20th century. Researchers considered them an opportunity to explain better and potentially achieve a general theory. Talcott Parsons, an American sociologist, is a key figure in system theories and referenced by Luhmann. Parsons was influenced by Weber, from whom we got one definition of power. Now, you might wonder why I keep bringing up system theory in social sciences while computers are considered systems. What is so special about social science? Its theories are always dealing with something unexpected or complex. Remember that example from international relations. If you try to abstract your model to only have states, political entities here, you might realize that states are acting differently, and if you start to look for explanations, you need to open that black box state. Social science theory needed to deal with complexity from its beginnings, and I would argue that this was different from computer science. Show of hands, please, virtually, who has been in the situation that they pulled a lever in a production environment and the system reacted differently from what was expected. Was this because of complexity? I guess so. And based on Luhmann, I would define a complex system as one where a specific action can lead to different outcomes, that the system is contingent. In Luhmann's words, again roughly translated by me, an interconnected set of elements is complex if it is no longer possible for each element to be linked to each other because of inherent limits of the element's linking capacity. An easy solution would be to design systems in a way that they never reach that limit. I have tried that, and I guess you have been trying that too. Is it possible to succeed? Not if the elements in your system need to interact with the system's environment. Luhmann's explanation for this is based on how a system differentiates itself from its environment, and we skip those details. Let's assume instead that for us inside reliability engineering, any system has a tendency to reach these limits. How can we reduce complexity then? Luhmann says, nur Komplexität kann Komplexität reduzieren. Only complexity can reduce complexity. That doesn't sound very practical. What does Luhmann mean? One possible solution, he suggests, is to replace one of those networks of links with another network that is less complex. Complexity will not disappear, but the number of possibilities declines, and hence we should be able to reduce the risk inherent in the system. He was writing this in the 1980s. This seems like a key argument to use something like Kubernetes for a production environment. In a world before Kubernetes, my production environments were a set of scripts and machines configured in a specific way. Kubernetes reduces that by standardizing that risk inherent in that configuration. Meanwhile, this is only explaining the past. Can we transfer the new knowledge to new problems? We should be looking for standard solutions for the next level of complexity, replacing code with configuration, to paraphrase one of my mentors. I promised that this is relevant for debugging a production environment, and here is an example. Imagine you have a larger service operating in production and suddenly your error rate increases. Not a lot, but enough to hurt your SLA if it continues. You do the usual investigation and the errors are local to one of your production clusters. Is there a different version of some service running? You identify the service that has a higher error rate, but you cannot find any significant differences to other clusters. You turn off that specific cluster, and the error rate increases in another cluster. It is clearly a complex system, and what you can conclude with Luhmann is that something in the environment must have changed. Looking at random RPCs, however, does not really help, as the error rate is close enough to noise. But what we consider as environment for our system/service is another system. What kind of system could cause enough requests to our service to be noticeable and not be conformed to standards to trigger errors, and would appear in one single cluster, moving to one another close by cluster as described? Most likely a friendly bot querying our API, not fully compliant with all standards, which, once you suspect, can easily be confirmed by slicing the traffic for user agents. Back to Luhmann's theory, it contains a lot of interesting ideas, and it would be interesting to explore them further. Due to time, I picked 4 concepts somewhat at random. Briefly, complexity can also be the information that a system is missing to describe or recognize itself or its environment completely. Luhmann suggests that this can be modeled in the system as an unknown factor as risk. It would be interesting to discuss the implications of this for system design, to actually actively model risk. How do you design a system that way? How do you describe it? However, we are just scratching the surface of possibilities here. The self-organizing system needs to have boundaries, and that requires a beyond. It also creates the possibility of crossing that boundary. In system design, you might want to optimize for that. Do not assume that there is nothing outside of your system and that the boundaries will never be crossed. At those border checkpoints or APIs, the system will never be able to process the full complexity of the other systems. Applying this to system design, make sure that your API does specify what inputs are allowed and how to react to invalid input. If your frontend allows Unicode for users' names, but one of the legacy backend systems only accept ASCII characters, it is unlikely that all users will have a good experience. A self-reproducing system also needs to be self-referential. And another important distinction, it does not have an identity. Its description is based on the difference to the environment. Again, for a simple service, this distinction might not be particularly valuable, but for the complex systems we are dealing with in our jobs, I think this is an interesting exercise. Can you design or describe your system just by using the difference to its environment? Finally, this also means that the relationship with the environment is fundamentally different due to the complexity of the environment, which is always more complex than the system itself. The system cannot control the environment. Instead of designing a system, it should have autonomy and environmental awareness. It does not know everything about its environment, like in the earlier example of the username and the char sets. This is just a short glimpse into Luhmann's theory of social systems. In a way, there are a lot of interconnections between what I mentioned, and I could link this to more best practices we might be already familiar with. That being said, it might just shift your attention towards a system's boundaries and environment, and political science gives you a new perspective on how to reduce complexity, which is constant work, not a one-time change. Let me finish with that image of the system in its environment. It suggests to us not to control a system completely, but build it in a way that it is aware of its surroundings and has some degree of autonomy that allows it to reproduce itself with time. I talked about 2 at first sight quite different topics picked from political science. In the first part, I looked at power and how it influences human behavior. I argued that in a network organization, like most modern software engineering companies, change can only happen in a very specific way, and tried to provide the theoretical foundations for that with an introduction to political science. In the second part, I picked one theory, Luhmann's, and applied it to our technical practices, system design and debugging. Both are tied together by a realization that social constructs do matter, what is called the constructivist turn in international relations, and the idea of autopoiesis in system theory. In the end, however, it is important to keep in mind that values do matter too. As I mentioned briefly, cooperation works best if you share some basic principles and if you can trust each other. That requires respect. Did I convince you about the advantages of a network organization? Do you think differently now about complexity and how you can design systems to reduce it? Looking forward to hearing from you. I hope my talk was somewhat surprising and maybe I got you interested in learning more about political science. Thanks for listening.